Welcome to Oracle 11g R2 Grid. This is the introduction to 11g R2 Grid infrastructure facility, and we're going to talk about the basics, the changes that have taken place in 11g R2, 10g up till 10.205 and 11g R1 had similar architecture. If you have not gone through the 10g rack videos, I highly recommend you do that. The basic change for Oracle Grid infrastructure architecture is that the ASM and Oracle clusterware are now installed into a single home directory called Oracle Grid Infrastructure. You will also hear this directory referred to as Grid Infrastructure Home. So Grid Infrastructure Home has combined the clusterware home and ASM home into a unified binary structure. So what is a cluster? It is a group of independent but interconnected computers that act as a single system. It is usually deployed to increase availability and performance or to balance a dynamically changing workload. Cluster cannot be used to enhance your bad performing SQLs. If a single node is running a SQL which is not offering the desired response time, putting that SQL in a grid infrastructure is not going to make it go faster. So grid infrastructure is used for scalability. It is used as a subsystem which is going to act as a single unit for the end applications. It can be used for performance tuning as it relates due to lack of resources. Hence, the better terminology to be used is scalability. So performance issues caused because of scarcity of resources can be eliminated by adding additional nodes in the system. Hence we are adding more capacity because the end applications will now see a combined capacity at its disposal. Now DBAs will have to configure the applications to see how they will be able to use that, how they can bind the application to specific nodes through specific virtual IPs and things of that nature, how they will be performing load balancing, or you will let Oracle do it for you. So the two purposes which will be served by getting into the cluster architecture: high availability is the primary thing, and the second thing is scalability and indirect performance gain due to scarcity of resources. So that is very important to understand. If your code is experiencing problems because it is not well written, designed, or SQL is not well tuned, you have to tune your SQL first in a single instance environment before you deploy it in a cluster. So Oracle Cluster is a key part of grid infrastructure. It is integrated with Oracle Automatic Storage Management. It serves as the basis for ASM Cluster File System, ACFS. So ACFS, in olden times we had OCFS, which was sitting on top of your shared device. Then Oracle came with ASM. ASM will manage your raw devices called logical units, called LUNs. These logical or devices, basically your raw partitions, are managed by ASM. So there is no, an Oracle will do direct I/O. There are two ways to writing I/O in Oracle: buffered I/O and direct I/O. When you have ASM managed storage system, you are going to be using direct I/O, bypassing all the OS buffer cache potentially, as well as other caches involved in the I/O path. Now there is also a side effect you will see by doing direct I/O, because you will lose the read ahead capabilities of the system. So you will see what happens, for example, if you are using Veritas cluster file system, or just say Veritas file system, and the operating system is detecting that we are doing a full table scan or fast full index scans, it will intercept. As you know, we are going to make the calls from Oracle kernel to the OS to do the I/O for Oracle. It will know that we are expecting that we will be reading a lot of continuous blocks because of full table scans, right? So it will know this, and it will try to prefetch the data from the storage unit and cache it locally in OS buffer area. If you go to direct I/O architecture, that facility will not be available. Although you're doing direct I/O, which is the fastest way of doing I/O, you will have this negative effect. If you're doing a lot of full table scans in your system, they will become a little slower. We have seen up to 40% slowness for large full table scans. As the cache gets warm, that means the blocks are being cached. As time goes on, you will see that the overall system will start behaving properly and a little bit better. The solution in this case might be, if you're doing a large table scans like these, where you must do full table scans and you must do direct I/O, you may have to go and change the number of threads going after a specific table segment, which means you may have to enable degree of parallelism on this table. So you may be finishing your job using, let's say, 50 processes. Now, because you may have to add 4 or 5 parallel threads per large table, you may end up using 400, 300 net processes to do the same job. So be aware of these things when you go to ClusterWare. So that is part of your ASM and doing direct I/O. Now in 11GR2, Oracle has come with ACFS, which sits on top of your ASM, which is a file system from Oracle, which can be used by any type of file, not only data file. You can also put Oracle Homes, your Apple tops, common tops, and things of that nature. So, Oracle Clusterware is a generalized cluster infrastructure for all kinds of applications. Let's dig deeper. So, Oracle Clusterware is a key part of Oracle Grid infrastructure, which also includes Automatic Storage Management (ASM) and ASM Cluster File System. In the release 11.2, Oracle Clusterware can use ASM for all the shared files required by the cluster. Oracle Clusterware is also an enabler for the ASM cluster file system, a generalized cluster file system that can be used for most file-based data such as documents, spreadsheets, and reports. The combination of Oracle Clusterware, ASM, and ACFS provides administrators with a unified cluster solution that is not only the foundation for the Oracle Real Application Cluster databases but can also be applied to all kinds of other applications. If you are aware of 10G or 11G R1 rack, when you install Clusterware, the prerequisite for that is you need to have two raw partitions or two block devices allocated for Clusterware installation. One of them is the voting disk and one is OCR location. So you need to have one device for voting disk and one device for OCR. That logic was applied all the way until 11G R1. Now in 11G R2, these two components can be part of ASM. In 11G R1 and 10G R2, unless you have installed Clusterware, you cannot install ASM. Now we are saying that you can install Clusterware components into ASM. That means logically they have to be combined together, and that is what has happened. Now in 11G R2, Clusterware and ASM software is clubbed into a single directory, a single binary system, and during the installation of cluster itself, all you need is to provide a disk group, and that disk group will host the OCR and voting disk. There is no need to have your block devices or raw partition anymore in 11G R2 Clusterware installation, which also means you cannot separate, if you want to, you cannot separate the Clusterware home from ASM home anywhere in any situation in 11G R2. But there's exception. If you are upgrading from 10G R2 to 11G R2, right, from 10G to 11G R2, you have an option to upgrade your Clusterware and then upgrade your ASM. Only in this upgrade situation you will have the capability of separating Clusterware from ASM. All the new installation, that is not possible. Architecture and services. As we said, Oracle Clusterware combines the accessibility to the shared storage via a network switch, a storage switch, sorry, which combines all the servers through interconnect to the user through a normal network. So if you look at the diagram, the end user makes a call to access the application database. It makes a connection to the typical network connection. There will be scan IPs. There is a TNS name, listener configuration, and you get connected through interconnect to any of the nodes. So what happens is user doesn't know where on what machine it will get a session into. There is a local listener running on each machine. There's a scan IP running on 3 of them. We will talk about this now. So when the user makes a connection through the network, there's no guarantee where it's going to go. It is going to go to one of the scan IPs, which will intercept the connection and then pass it on to local listener. Now if the scan IP is on machine say 1 and 2 and say 5, and you may get connected to scan 1 on machine 1. So the interconnect is used for inter-process communication. Blocks will be transferred, global cache fusion as you talk about. Also it is used for transferring the connection. Once the connection is established to scan IP is going to direct the connection to one of the least loaded node. One of the node which is least loaded. That means it has CPU, IO, or memory wise it has less load on the system. So you will be transferred internally to that specific node. Once that node is identified, listener will have a direct connection to the user. You will not communicate through any other means, right? So your user session will be now hosted on specific node and you have a direct connection. So you start sending your SQLs, DDLs and DMLs, it will be running on a specific node. So even if you have such a huge number of machines, you will be connected to a single instance and you will stay connected there once you have this connection established. And once you run your SQLs, depending on if you're running parallel queries, you want to localize them or you want to distribute them across all the servers, or if your data is already in one of the local memory cache of any of the servers and you are running the same SQL and the data is consistent, there is a GRD global resource directory which is maintaining number of blocks where they are, right? So it says okay, this guy is running the same SQL which already has data elsewhere in node 5. So it will use interconnect and fetch the data from memory of machine 5 into memory of machine 10, hence serving the user effectively without even doing I/O. This is simplified version of the diagram I'm trying to explain, right? So you always have to have fabric architecture, storage network. You have EMC or Hitachi or HP or Sun storage, and you will be slicing your LUNs from all these storage units which will be attached to a specific port on a fiber switch, and then they will be connecting to all these servers through HBA. Just like the network card which is inside every machine, you also have one more card for I/O called HBA, host bus adapter. It is going to extend your I/O from within the server to the external storage, and that is what this diagram is showing. So the services in the clusterware, we cannot talk about that in much more detail, but services include cluster management services, node monitoring, event services, time synchronization services, network management, and high availability services. What is the goal of Oracle Clusterware? It is easier installation, easier management, continuing tight integration with Oracle RAC. ASM enhancements will benefit all applications. No additional clusterware is required. When you are using Oracle ASM, you don't need any additional clusterware. So if you want to do NIC bonding or you want to do multipathing, all these facilities are now available and part of the OS kernel itself. It is true for Linux, it is true for HP Unix, it is true for Sun Solaris. I'm not sure about EIX. So if you are using these latest versions of operating systems, they have inherent capability of doing multipathing, which means you have multiple HPAs for high availability which you need to configure. You also have NIC bonding, which means you have multiple NICs which need to be bonded together and set up an active passive failover, which we will talk about in the next slide. So no additional clusterware should be used or is required to sit on top of Oracle clusterware just for the sake of justification of doing NIC bonding or doing HPA multipathing. That is done by kernel of OS itself. Oracle clusterware doesn't provide that facility, but that is not required either by anyone. So do not get into the trap of having to buy additional clusterware which has to sit on top of Oracle clusterware to manage the NICs or manage the HPAs. So let's get into some basic components here. Oracle clusterware networking. Each node must have at least 2 network adapters. Each public network must support TCP/IP. The interconnect adapter must support UDP, which is User Datagram Protocol, or Reliable Data Socket (RDS) for Unix and Linux for database communication. TCP for Windows platforms for database communications. All platforms use Grid Interprocess Communication (GIPC). We will talk about GIPC more. So now, how do we set up the link aggregation in a single switch? If you see the diagram here, each node has ETH0, ETH1, and they are bonded together and they are both connected to the interconnect. So link aggregation can be used to increase redundancy. That means if the first Ethernet card fails, the second will take over the operation. So to increase redundancy for higher availability with the active standby configuration, link aggregation can be used to increase bandwidth for performance with the active configuration. So if your data which is being transferred between the nodes is pretty high, you may want to do active configuration of the Ethernet cards. So you can do active or active passive. This is single switch. This next diagram is typically what is configured and what is recommended. So interconnect link aggregation in a multi-switch. So we need to not only see, the moment we talk about Oracle clusterware and Oracle RAC, we are talking about setting up various things. First, that we are not going to have any point of single failure in the whole infrastructure. Your NICs, your HPAs for IO, your NICs for interconnect, your NICs for connectivity to the applications or the end user, right? Your NICs or HPA backbone for your backups, right? Depends on how you're setting up the backups. And your software components, your LUNs, at any level of the architecture, you will not have any single point of failure, which also applies to your interconnect switches. So if you just have single switch and you do link aggregation, then that switch might be the point of failure. If the switch goes down, all your rack nodes will crash and you will have a split brain scenario. We don't want that. So you will always have your connections getting into the multi-switch configuration as shown here. So the redundant switches connected with an inter-switch trunk may be used for enhanced high available design. This is the best practice configuration for the interconnect. So all your within the server you have two cards at least, and they are bonded together, and once that is done, the active one will go to switch 1, the passive one, the standby, will go to switch 2, and same logic will apply on every node. So all the active Ethernet cards for the interconnect will get plugged into the same single switch port. All the standbys will go to the passive switch. Additional interconnect guidelines. UDP socket buffer. The default settings are adequate for majority of the customers. It may be necessary to increase the allocated buffer size when the MTU size has been increased. The netstat command reports errors. ifconfig command reports dropped packets or overflow. Or the jumbo frames are not an. So you can also use jumbo frames if you want to. It is not an IEEE standard. They are used typically for NAS or iSCSI storage. Have network devices interoperability concerns. You have to test it thoroughly. Oracle has a MetaLink note which tells you what needs to be done if you move to jumbo frame. So you have to, what happens is your packets are now broken into smaller chunks. If you want a bigger packet size transferred in the interconnect using jumbo frames, you have to have a bigger bandwidth for the network, not only on the network card but also the switch has to support it. Switch has to support whatever you want to do with your network card. So switch and the Ethernet card must support jumbo frame based transmission along with the operating system, and then we have to change the settings for Oracle as well. Oracle Clusterware architecture. Oracle Clusterware is started by the OS init daemon, and this is the flow which takes place. So operating system init domain, this init process, under that etc init.d there is init.ohasd. Oracle High Availability Service daemon. Now any script, as you know, under init.d will be run during startup and shutdown depending on at which level they have been configured. In either case, you have init.ohasd script which will run, and when the script runs, it will start all the Oracle Clusterware processes listed in the box on the right side: OHA, AS.bin, OCSSD.bin, EVMD.bin, CRSD.bin, right? So all these processes will be spawned by init.ohasd. Oracle Clusterware installation modifies the /etc/init.deb file to restart OHASD in the event of a crash. And this is something you can look at when your installation. How the configuration looks like. So if you open that etc init tab, you will see init.ohasd has been configured. Oracle Clusterware startup. Let's talk a little bit in much more detail now. During the installation of Oracle Clusterware, the init.ohasd startup script is copied to etc init.d. The wrapper script is responsible for setting up environment variables and then starting the Oracle ClusterWare daemons and processes. The Oracle High Availability Service Daemons, OHASD, High Availability Service Daemon, OHASD, is responsible for starting in proper order, monitoring and restarting other local Oracle daemons up through the CRSD daemon, which manages cluster-wide resources. So Aura root agent will start CRSD. CRSD starts another Aura root agent process responsible for root-owned CRS resources, including the scan VIPs. CSSD agent starts CSSD and OCSSD. Aura agent starts MDNSD, which is multicast DNS daemon, EVMD, ASM, CTSSD, and GPNPD. Aura agent also starts GST, Oracle Notification Service, and the listeners. Right. So if you look at this diagram, this starts all these processes, but there's a flow to it. There are various agents which will be responsible for starting various resources. Right. So all these daemon background processes are running. Some of them will be running as root, some of them will be running as Oracle. Those running by root needs to be started and stopped as root user. You cannot run some few commands which will require you to have a login into root, right? So if you don't have access to root, or you're not having the capability to run some scripts which will affect root owned resources, that means you will not be able to start and stop or manage those resources as Oracle user. This is a snapshot we took from Oracle. CRS is cluster ready services. The process is CRSD. Owner is root. Cluster synchronization services, CSS. It will start OCSSD, CSSD monitor, CSSD agent, and owner is grid owner or root. Event manager, EVMD, process will be started by that EV, and then EVM logger, and the grid software owner will own this process. CTSS is cluster time synchronization service. OCTSST is a process name and it will be owned by root. ONS is Oracle Notification Service. Process is ONS and EONS, and the owner is grid owner. Oracle agent is Aura agent. Owner is grid owner. Oracle root agent is Aura. Is going to start Aura root agent process. Owner is root. Grid naming service GNS and grid plug and play GPNP, as you can see, are owned by root and grid owner respectively. Right. So just not to remember this, just to know, be aware what service is started by what component and who owns it. Because if you try to shut down CRSD as Oracle user, unless you have the permission on the script to do that operation, it will not work, right? So we will see when we start doing some commands that some commands will require you to have root access to operate on those daemons. So critical grid processes. Oracle ClusterWare comprises several processes that facilitate cluster operations. The Cluster Ready Service CRS, Cluster Synchronization Service CSS, Event Management EVM, and Oracle Notification Service ONS components communicate with other cluster components layers in the same cluster database environment. These components are also the main communication link between the Oracle database application and the Oracle cluster high availability components. In addition, these background processes monitor and manage database operations. The following list describes some major Oracle ClusterWare background processes. First one is CRS, Cluster Ready Service. In the primary program, it is the primary program for managing high availability operations in a cluster. The CRS process manages two types of CRS resources: cluster resources or local resources. A cluster resource is an Oracle ClusterWare resource. Cluster resources are viewed, added, modified, or removed using the CRS-ctl command. Local resources. A local resource runs on every node in the cluster, and there is no failover for that resource, and can be, for example, a listener, an ASM, a disk group, or Oracle Notification Service. The CRS daemon, CRSD, manages cluster resources based on configuration information that is stored in the OCR, which is Oracle Cluster Registry. If you take a OCR dump, as we have shown you in 10G, you will see, we'll also show that in this practical also, you will see if you take OCR dump as root user or take a OCR dump as Oracle user, some of the information is hidden when you take a OCR dump from Oracle user, because it is a subset of the larger set owned by root, right? So for example, GNS will not, if you take a OCR dump, you will not see GNS information in the Oracle dump. GNS information will be visible from the root dump. Anyway, the CRS is going to manage the resources which are listed in the OCR. This includes start, stop, monitor, and failover operation. The CRSD process generates events when the status of a resource changes. Continuing on that discussion, when you have Oracle RAC installed, the CRSD process monitors the Oracle database listener, instance, and so on, and automatically restarts these components when a failure occurs. When a CRS fails, the CRS daemon attempts to restart it. If the resource is also configured, CRS fails the resource over to another node, again if it is configured to do so, after exhausting restart attempts. So when a resource goes down, it will try to start it automatically. For example, if your listener goes down or an instance goes down, CRS will try to restart a couple of times. After it has exhausted those retries, the instance or the listener will be copied over to the surviving node. So one of the nodes will have instance 1 and instance 2. CSS, Cluster Synchronization Services. It manages the cluster configuration by controlling which nodes are members of the cluster and by notifying members when a node joins or leaves the cluster. If you are using certified third-party clusterware, then CSS process interferes with your clusterware to manage node membership information. CSS has 3 separate processes. CSS daemon. If you do ps-ef and grep CSS, you will see OCSSD. It also has CSSD agent and CSSD monitor. The CSSD agent process monitors the cluster and provides input-output fencing. This service formerly was provided by OPROCD, also known as Aura Fence service on Windows. A CSSD agent failure results in Oracle clusterware restarting the node. So Oracle process CSSD agent. Is critical. If CSSD agent goes down, Oracle clusterware will restart, which means it will restart the instance and the listener as well. And all the users who are connected on that node will get an error, and when they reconnect themselves again, they will be directed to a surviving node. Okay, let's continue the discussion of critical grid processes. The next one is disk monitor daemon, diskmon. It monitors and performs input-output fencing for Oracle Exadata storage server. Event Manager is a background process that publishes Oracle clusterware events. Multicast Domain Name Service, MDNS, allows DNS requests. The MDNS process is a background process on Linux and Unix and a service on Windows. A GNS is a gateway between cluster MDNS and external DNS server. So the GNS process performs name resolution within the cluster. The GNS is a new concept in 11GR2. Scan and GNS, again as I said, is a new concept and is part of 11GR2 clusterware. We will talk about these scan and GNSs shortly. Aura Agent extends clusterware to support Oracle specific requirements and complex resources. It runs server callout scripts when fan events occur. This process was known as RAG-G in clusterware 11GR1. So RAG-G, which was used for running server callout scripts when fan event occur, right? Now that process has been renamed or remodified. Now it is done by Aura Agent. Aura Root Agent is specialized Aura Agent process that helps CRSD manage resources owned by root, such as a network and a grid virtual IP address. Cluster Kill Daemon OCLS-KD handles instance node evictions requests that have been escalated to CSS. Grid IPC daemon GIPCD is a helper daemon for communications infrastructure. So among all the processes, you need to understand at least in detail what MDNS is, what GNS is, what scan is, and if you are doing server fan callouts, how to use Aura Agent, right? And it is a CSS agent, Aura CSS agent, as we talked earlier. Let's go back there. This Aura CSS agent, right? The CSSD agent, this is your CSS agent, right? The CSS agent, the failure of CSS agent, this might be a question for interview, results in Oracle clusterware restarting. Alright. So be aware of these basic services. Grid plug and play. In previous releases, adding or removing server in a cluster required extensive manual preparation. In Oracle Database 11 GR2, GPNP Grid Plug and Play allows each node to perform the following tasks dynamically: negotiating appropriate network identities for itself, acquiring additional information from a cluster configuration profile, configuring or reconfiguring itself using profile data, making host names and the addresses resolvable on the network. To add a node, simply connect to the server to the cluster and allow the cluster to configure the node. We are going to have a practical demonstration of that in detail with all the commands. GPNP domain is a collection of nodes belonging to a single cluster served by the GPNP service. For example, the cluster name can be cluster, network domain can be orabyte.com, hence the GPN domain becomes cluster.orabyte.com. So each node participating in a GPNP domain has the following behavior: must have at least one routable interface with connectivity outside of the GPNP domain for public interfaces, a unique identifier that is unique within the GPNP domain, a personality affected by GPNP profile, physical characteristics, and software image on the node. GPNP components. A software image is a read-only collection of software to be run on nodes of the same type. At minimum, the image must contain an operating system, GPNP software, a security certificate from provisioning authority, other software required to configure the node when it starts up. Looking at GPN profile, it is under grid home, GPNP, profile sphere, profile.xml. This is how it looks like. Multicast DNS. Multicast DNS or MDNS provides a naming service system that is easy to set up and maintain for computers on a local link. All participating network devices on the same local link perform standard DNS functions using multicast DNS rather than unicast, and do not need a unicast DNS server. For admins, the primary advantage of MDNS is that no unicast DNS server needs to be maintained on the local network. There is no need, for example, to update and maintain host names in files to resolve host names to IP addresses for devices on the local link that are using MDNS. So, there is a file called nsswitch.conf. Now we will be modifying that during installation, as you will see. So think about is that if you remember, we had a GNS service. The GNS service is a middleman between DNS and MDNS. Let's go back to that. Now here, Oracle Grid Naming Service is a gateway between the cluster MDNS and external DNS server. GNS process performs names resolution within the cluster. Right? So the GNS performs name resolution within the cluster. Very critical to understand. And when we do the installation, we will be doing installation using GNS based IP, where all the IPs will be obtained using DHCP, and these IPs will be used by scan IPs as well as listeners. All the interconnect VIPs and listener VIPs, scan VIPs, right? All those, maybe application VIPs if you customize that. All those will acquire IPs dynamically through DHCP because you have configured a GNS. All the names will be resolved. So this GNS is a middleman between external DNS and cluster MDNS. So if you go with the GNS architecture, you will have a single static IP that is for GNS. Everything else, we haven't talked about scan VIPs or the application VIPs, right? All those IPs will be obtained dynamically from DHCP. There is no IPs required anywhere to be put into local hostname file. So in 10G and 11GR1 we will have etc host files which will have the IP addresses for interconnects, right? It will have IP for public network cards and the VIPs. So VIPs and the private connections, right, and the public connections, they will all be located as an IPs. In GNS we don't need to do that. That's the main thing, and that is what they might ask you, what is GNS, what is scan, and under what condition we will want to go into GNS configuration. When you are managing a lot of nodes in a cluster and you are going to manage a lot of IPs for interconnect, which was configured as private IPs for interconnect, right? And then the VIPs which are used for the public interface, right? Floating IPs was floating IPs. And the idea is still the same. You still have VIPs as a floating IP. You still have private interconnect for your inter-process communication. But the IPs to the host name resolution was done through local etc host name file, if you remember that in 10G and 11GR1. Now you have a facility to get away from that model using GNS configuration. So what is GNS? GNS is an integral component of grid plug and play. The only static IP address required for the cluster is the GNS virtual IP address. That's it. And to find out and to change the GNS IP using commands we will show you later in the practical component, you will have to log in as root. If you do OCR dump as Oracle user, you will not find the GNS settings there at all. And if you do take a OCR dump from the root user, you will have to observe and locate GNS entries and the IP address for that. And when the cluster reboots, you can see you can get a new IP if you change it. That we will show you in the practical demonstration. But if you go to this GNS architecture, the only static IP address will be that of a GNS virtual IP address. That's it. Everything else will be coming from DHCP. So you have to set up subdomain, delegate a list of IPs, ranges, set up your DHCP, and then all this magic will work. We will show you that in the practical to make much more sense of this. So if you're managing 10 node cluster, 20 node cluster, 100 node cluster, going to GNS might be the way to go, because you don't have to manage 3 IPs per node times 10 is like 30-40 IPs being managed, right? And that is per node. And then if you have 20 nodes, you are managing 60 IPs, and 60 IPs are listed in each of the etc host file. So there is a probability of spending and making some mistakes and spending a lot of time managing this. We don't need that anymore if you have a large cluster where having a lot of nodes. The cluster subdomain is defined as a dedicated domain. If you look at the cat etc, if you do a cat on etcnamed.conf, you can see the delegate to DNS on cluster 01, and it is specified that as cluster.orabyte.com, which is your cluster subdomain. And then you have cluster-gns.orabyte.com, which is your cluster GNS static IP address. So when the clusterware is trying to resolve an IP, it knows when you restart a node, it needs to get IP, right? It has to contact GNS and say, give me IPs for VIPs and private interconnects. It has to find that GNS. address, and this is how it's going to find. A request to resolve cluster01-scan.cluster01.example.com would be forwarded to the GNS on 192.0.2.155. So the name resolution, because ultimately your name has to be bound to an IP address. So when you are specifying that I want to go and resolve cluster01.scan, for example, right, .cluster01.example.com, I need to go to GNS to get the information. Each node in the cluster runs a multicast process. MDNS is running on every node of the cluster. There is one GNS static web address, one GNS virtual IP address in the whole cluster, but each cluster node has its own MDNS process running. And MDNS, multicast DNS, will contact GNS, which will be interfaced to the external DNS. So GNS naming grid naming service, employing grid naming service, GNS assumes that there is a DHCP server running on the public network with enough addresses to assign to the VIPs and single client access name, scan VIPs. So the VIPs on the application and VIPs for the scan will dynamically get the IPs from DHCP server. And GNS assumes that you have enough DHCP IPs configured so it can allocate when the name resolution is done for the VIPs, VIP application VIP name and the scan VIP name, it knows it will go and get it from DHCP. It is our responsibility based on the IPs we will need to configure DHCP to have the pool of IPs ready to be used by GNS. This address, so with the GNS configuration, only one static IP address is required for the cluster, the GNS virtual IP address. This address should be defined in the DNS domain. GNS sets up a multicast DNS server within the cluster, which resolves names in the cluster without static configuration of the DNS server for the other node IP addresses. So let's read that again. Most critical information in 11GR2. With GNS, only one static IP address is required for the cluster, and that is for the GNS virtual IP address. This address should be defined in the DNS domain. The GNS sets up a multicast server within the cluster. And as we just saw, that this multicast DNS will be running on each node of the cluster. And this MDNS, which resolves names, is used to resolve names in the cluster without static configuration of the DNS server for other node IP addresses. Alright, so let me read that again. GNS sets up a multicast MDNS server within the cluster. MDNS process will be running on each node, and this process resolves names in the cluster without static configuration of the DNS server for other node IP addresses. So the MDNS server works as follows. Within GNS, node names are resolved using link local multicast name resolution, LLMNR. It does this by translating the LLMNR .local domain used by multicast resolution to the subdomain specified in the DNS query. When you select GNS, an MDNS server is configured on each host in the cluster. LLMNR relies on the MDNS that Oracle ClusterWare manages to resolve names that are being served by that host. To use GNS before installation, the DNS administrator must establish domain delegation to the subdomain for the cluster. Queries to the cluster are sent to the GNS listener on the GNS virtual IP address. When the request comes to the domain, GNS resolves it using its internal MDNS and responds to the query. Alright. So before you set up the GNS based clusterware, you have to talk to the DNS admin folks and establish domain delegation to the subdomain of a cluster. So you'll have to create a subdomain and then you have to do the delegation. We will show you using Windows in our practical, and the idea is that the queries sent to the cluster are sent to the GNS listener. Right? There's one static IP address that is for the GNS virtual IP. Using that DNS virtual IP, there will be GNS listener, which is listening for the name resolution. Alright, so when the request comes to the domain, GNS is going to resolve it using its internal MDNS. And as I told you that each server will be running its MDNS. So there are 10 node cluster. Each node is going to have its own MDNS copy or a process running. The second most critical component in 11g-R2 is single scan access name. The single client access name, SCAN, is the address used by clients connecting to the clusterware. The SCAN is a fully qualified host name located in the GNS subdomain registered to the 3 IP addresses. So here this is the example of how the scans are registered. So SCAN is a fully qualified host name located in the GNS subdomain registered to 3 IP addresses. So remember that when we are going to use SCAN and GNS installation examples, we are going to be using the SCAN static IP addresses in one example for SCAN based installation. So we can bypass the GNS based IP resolution by having a static SCAN IPs. For the scans, SCAN is a new architecture for listener and the client connection, where you enter and connect to the SCAN name, not to the listener name. So let me probably show you this diagram here. So you have one GNS in the architecture, right, which has static IP, static VIP IP, and it is running its own listener called GNS listener. In the node of say n clusters, you will only have one GNS listener and one GNS virtual IP, which will be used by the listener. Then you have 3 SCAN VIPs. Each VIP will be used by something called SCAN listener. There are only 3 of them, and they will be distributed randomly on any of the nodes. So if you have 2 node cluster, one node will have SCAN listener 1, another node is going to have scan listener 2 and 3. If you have 3 node cluster, you will have scan 1, 2 and 3 running one scan listener on each. As I said again, to bind a listener, to start a listener, you need to have an IP address. This IP address is going to be for scan VIP. So scan listener will use scan VIP, which is an IP on which, so when you're having a service, when you're having a listener, it needs to have two things: IP and port, right? So each scan listener will have its own IP address. It needs its own IP address. So depending on number of nodes you have, Oracle will randomly distribute these VIPs on these nodes called scan VIPs, and these scan VIP IPs will be used by the scan listeners running on the same node where the VIP is running, obviously. Underneath that layer is the listener which we are used to seeing and working with. When the clients are connecting, they will connect to the scan listener. Scan listener knows about all the listeners underneath that, which are local listener for the nodes, and it knows which listener is least loaded, and it will incoming connection, which is from the client or the application, is going to be talking to scan listener. It will move that request to any of the listener which is least loaded, as shown here. So your scan listener may be running on node 1. That doesn't mean it will connect you to node 1. It might connect you to node 2 or 3 or 4, depending on what is the system load at that moment. All these scan listeners are aware of that. Second request comes in, he may get connected to scan listener 3. Third guy comes in, he may get connected to scan listener 3. The fourth guy comes, he may still get connected to scan listener 3. The fifth guy may get connected to scan listener 2. Right? So that is the initial connection interception or single point of entry into the cluster, where once you get that connection, it will direct your next connection to the local listener, and each node has its own local listener running on the local VIPs, application VIPs. So there are VIPs for each application which are used by listener. There's a VIPs for scan listener. There's a VIP for GNS. There are 3 VIPs here: GNS VIP, scan listener VIPs, and application VIPs. And then you can also have your own VIPs, customize them. Each node is having MDNS and GPNP also running. Alright. So let's go back and not skip this. So scan, a single client access name. Scan is the address used by clients connecting to the cluster, as I explained right just now using the diagram. Right? The scan is a fully qualified host name plus domain, registered to 3 IP addresses. If you use GNS, you have DHCP support, then GNS will assign addresses dynamically to the scan. If you do not use GNS, the scan should be defined in the DNS to resolve to the 3 addresses assigned to the name. So one scan name resolved by 3 different IP addresses. You are entering into the cluster using the scan name. One scan name is now having 3 different scan VIPs and 3 different listeners, which will intercept the connection and then pass it on to one of the local listeners. The diagram showed that 1 scan name, 3 scan VIPs, each VIP having its own scan listener. Then each node is having their own application VIP, and that default application VIP is using the listener, and is used by listener, and listener is running on that node. So there will be application VIP on each node, there will be listener on each node, right? If you're using a GNS, the IPs for these 3 scan VIPs can be dynamically obtained. If you're not using GNS, that's where you differentiate the installation. First, you have to decide, are you going to use GNS for all the IP resolutions or not? If yes, then even the scan VIPs will get the IPs automatically through GNS, as explained how, using the DHCP pool of IPs. If the answer is no before installation, then you decide that you will be using the static IP addresses for the scans. You're not using GNS for installation, you're using scan. So one scan name will resolve to 3 scan VIPs. So you need to have one name resolved by 3 different IP addresses. So this should be done before you install Oracle Grid infrastructure. The scan and its associated IP addresses provide a stable name for clients to use for connections, independent of the nodes that make up the cluster. Scans function like a cluster alias. However, scans are resolved on any node in the cluster. So unlike a VIP address for a node, clients connecting to scan no longer require updated VIP addresses as nodes are added or removed from the cluster. Let's try to understand this. When you are entering into the cluster, if you are using the 10G 11G R1 technology, if you have seen the TNS name file for that, you will see if you have 5 nodes, you will have 5 VIP addresses there: VIP 1, VIP 2, VIP 3, VIP 4, VIP 4, VIP 5, each pointing to the VIP which is localized on each node. So node 1 VIP 1, node 2 VIP 2, node 3 VIP 3, node 4 VIP 4, node 5 VIP 5, and each VIP is consumed by the listener. It can also be the customized application VIP and customized listener running on that VIP. All this VIP information must be present in 10GR2 and 11GR1 in your TNS entry. It's a huge maintenance which has to take place if you have locally distributed DNS names all over and different applications are doing different things. It's very hard to maintain and it's a nightmare. Even if you try to push the updated DNS names, people can modify it locally and still have issues. So to get around all these complexities, you enter into the grid using a single scan name. Simple as that, single scan name. And internally, all the magic will start from the single scan name. Your connection will be intercepted by scan listener, which is, there will be 3 of them distributed randomly on all the nodes. So you have 10 node cluster, but you will only have 3 scan listeners. They can be on any machine. Listener 1 will go to machine 10. Scan listener 2 can go to machine 5. Scan listener 3 can go to machine 6. It's a random distribution. The idea is that we don't have to hardcode the VIPs, scan VIPs into the TNS names of the clients. Just enter using the simple. We will show you that in the installation and post installation how the files are configured. So think about it, you're just calling something called Orabyte scan, and you log in and you make a connection from the application and say connect me to Orabyte scan. Internally, all the magic will take place between the scan listener and local listeners. Depending on how the load is on each node, scan listener will distribute the connection to the local listener, and local listener will give you the dedicated connection. And then you have a socket formed between that user server process and the client. But to make that socket connection, you have to go through these steps. Now each of these components requires IPs. We're discussing who will manage the IPs. Is it going to be subdomain delegation based? If you want to go all the way to GNS, in that case you have a lot of clusters to manage and you only have one static IP to manage. Rest are dynamically obtained by the GNS, DNS and MDNS model, and it will obtain the IPs for scan webs, listener webs from DHCP. If you do not want to go to that, then you have second option of installation, that is having a static scan IPs. In that case, GNS is not going to allocate the IPs for scan VIPs. Scan VIPs are required to start scan listeners. So what we have to do in this case is have one scan name be resolved by 3 IP addresses. So this decision is made basically during the installation itself. Scan listeners can run on any node in the cluster. Scans provide location independence for the database so that the client configuration does not have to depend on which nodes run a particular database. Oracle Database 11g R2 and later instances register with scan listeners only as remote listeners. Upgraded databases register with scan listeners as remote listeners and also continue to register with all other listeners. So when you're coming through the upgrade path, this is a critical point to understand. Remember, when you configure Oracle RAC, you have 2 init parameters, local listeners and remote listeners. Local listeners is where you're running your local listener, right? If your local listener is heavily loaded in the TNS, you also have entry for the remote listeners. So say you have listener 1, listener 2, listener 3, listener 4, listener 5. This is the name for node 1, 2, 3, 4, 5 listeners. Then you have remote underscore listener as a common name for remote listener, which will have the list of 5 VIPs which can be used to connect to the other listeners. This is how we have configured earlier, right? So if your connection is if you are planning to go to node 1 and that is heavily loaded, there's no guarantee that you will stay on that node when first time you're making that connection. The listener will detect that, hey, I'm heavily used right now. It will then make the connection and bypass connecting to the local listener, local instance 1, and it will connect, or it will direct the connection to I bypass the connectivity to the local listener and give the handshake to the remote listener. And how does the connection from listener, which is made specifically on listener 1, goes to some other random node 2, 3, 4, 5 listener? That is done through the translation of the remote listener, right? If a local listener cannot handle your request, Oracle Clusterware is going to use the least loaded listener concept and say, okay, hey, I will use the remote listener configuration and try to go to node 2 or 3 or 4 or 5. Alright, so that is why we need remote listeners configured. So local listeners and remote listeners. Just because you're connecting to remote listener does not guarantee that you will get connected there. It may use if it sees that it is not capable of handling that local connection and giving you a shadow process and creating a socket for you, it will connect to other listener to the remote listener configuration, which is configured in your local server tns name.ora file. So that is how we have done it in 11g R1 and prior to that in 10g, right? So we will show you the changes in the model when we do the installation and see how files are changed now. We are getting into the concept of scans now. Scan listener, scan VIPs, which is new. So during the installation, you have to make two decisions. Are you going to configure everything and automatically manage all the IPs using DHCP? Answer yes or no. Yes, then use GNS-based configuration. We will show you that in the installation process how to do that. Answer is no. Then you have option of doing 3 static IPs you have to configure for single scan name as an entry point, because in 11gr2 all the applications will use single scan name to get into the cluster, and from there it will do all the magic of load balancing and eventually getting the socket back to the application connection. So when you're doing the fresh installation, instances are registered with scan listeners only as remote listeners. When you're doing the upgrade to 11gr2, upgraded database is registered with scan listeners as remote listeners and also continue to register with all other listeners. If you specify a GNS domain during installation, the scan defaults to cluster name-scan.gns domain. If the GNS domain is not specified at installation, scan defaults to cluster name-scan.current_domain. We will show you that during installation. Scan and local listeners. When a client submits a connection request, the scan listener listening on a scan IP address and the scan port is contacted on the client's behalf. Because all services on the cluster are registered with the scan listener, the scan listener replies with the address of the local listener on the least loaded node where the service is currently being offered, the way I just explained. Finally, the client establishes connection to the service through the listener on the node where the service is offered. All of these actions take place transparently to the client without any explicit configuration required in the client. During installation, listeners are created on nodes for the scan IP address. Oracle Net Services routes application request to the least loaded instance providing the service. Because the scan address is resolved to the cluster rather than to the node address in the cluster, nodes can be added or removed from the cluster without affecting the scan address configuration. Right? So the key thing here to understand is that all services on the cluster are registered with the scan listener. All services on the cluster are registered with the scan listener. Very critical to understand. So what is a service? Everything in rack becomes a service. Instance is a service. Listener is a service. And they are all registered with the scan listener. So if you can add a node, if you are removing a node, so you're adding your action of adding a node, removing a node doesn't affect the client connection as it did earlier, because we are not hard coding any VIPs in the TNS files of the client anymore. We are just using scan name, and scan name has hard coded 3 IPs for 3 scan VIPs, and hence this configuration is not required to be changed because this is one-time configuration. So there will be 3 scan VIPs, 3 scan listeners managing the connection between the end client and probably to hundreds of listeners you may have on hundreds of nodes. Right? 20 node cluster, you have 20 listeners and 20 instances. You may have other application VIPs and application listeners as well. So you don't have to bother about knowing the instance listener VIPs as we did earlier. Those IPs and VIP names are not required. All you have to know is name of a scan. Simple as that. Scan names. Single scan name will have 3 static IP addresses. Static means they will not change for the cluster where it is trying to manage. So if you have prod cluster where prod cluster will have say 20 prod instances, then you may add and remove more instances without affecting the end client. That's the beauty of this new design. We're spending too much time here because this is the most critical concept. So during installation, listeners are created on nodes for the scan IP addresses. Oracle Net Services routes application requests to the least loaded instance providing the service. Because the scan address resolves to the cluster rather than to a node, that's the key thing. Scan address resolve to the cluster, not to the node. So that is how we can manage the clusterware in 11gr2. So scan name, scan VIP, scan listener. During cluster configuration, several resources are created in the cluster for scan. For each of the 3 IP addresses that the scan resolves to, a scan VIP resource is created and a scan listener is created. Everything is a resource, right? All the resources, as we talked earlier, there is CRSD daemon process which manages rack resources. Everything has to be a resource which has to be maintained by the clusterware. Scan VIP is a resource. So you have 3 resources. If you do AOCR dump, you will see 3 scan resources listed there with their own IP addresses. Now these scan resources will be used by the scan listener. The scan listener is dependent on the scan VIP, and the 3 scan VIPs will be dispersed across the cluster. This means each pair of resource scan VIP plus listener will be started on a different server in the cluster, assuming the cluster consists of 3 or more nodes. If you have 2 node cluster and you must have 3 scan IPs, scan IP1 will go with scan listener 1. Scan IP2 will go with scan listener 2. Scan IP3 will go with scan listener 3. If you have 2 node cluster, one cluster will have 2 scan VIP listener combination, and the second node will have only 1. If you have more than 2, then there will be one pair of scan VIP and listener per node. This is what I just told you. In case of 2 nodes, one server in the cluster will host 2 sets of scan resources under normal operations. If the node where the scan VIP is running fails, the scan VIP and its associated listener will fail over to the another node. So that is the reason we are using floating IPs. Virtual IP is a floating IP concept. If the node which is hosting your scan VIP and the listener fails, the scan VIP and the listener will fail over to the surviving node. If by means of such a failure the number of available servers in the cluster becomes less than 3, one server would again host 2 sets of scan resources. If the node becomes available again, the formerly mentioned dispersion will take effect and relocate one set accordingly. This is the diagram we talked about earlier. Skipping that. How GPNP works. The IP addresses are negotiated for public interfaces using DHCP, right? Which includes VIPs and scan VIPs. A GPNP agent is started from the node's clusterware home. The GPNP agent either gets its profile locally or from one of the peer GPNP agents that responds. Shared storage is configured to match profile requirements. Service startup is specified in the profile, which includes grid naming service for external name resolution and single client access name. So client database connections. In a GPNP environment, the database client no longer has to use the DNS address to contact the listener on the target node. Instead, it can use the Easy Connect method to connect to the database. When resolving the address listed in the connect string, the DNS will forward the resolution request to the GNS with the scanned VIP address for the chosen scan listener and the name of the database service that is desired. In Easy Connect syntax, this would look like scan-name.cluster-name.company.com/service name, where the service name might be the database name. The GNS will respond to the GNS server with the IP address matching the name given. Matching the name given. This address is then used by the client to contact the scan listener. The scan listener uses its connection load balancing system to pick an appropriate listener, whose name it returns to the client in an OracleNet redirect message. The client reconnects to the selected listener, resolving the name through the call to the GNS. The scan listeners must be known to all the database listener nodes and the clients. The database instance node cross-register only with the known scan listener, also sending them per service connection metrics. The scan known to the database server may be profile data or stored in OCR. Alright, so this I think should cover the typical scenario for knowing the basics. I think this is the last slide here. So DNS responsible for IP address resolution of the scan VIPs and server VIPs. Right here on the left side you see desktop clients. It can be Oracle application clients or Oracle J2 EE application, anything you like. And then you see there are 3 scan listeners, and then we have various database listeners, so as we talked about, and then from there, depending on the least loaded listener, it will make the shadow connection. Once that is established, where you will eventually go to, the client will end up having a connection, direct connection between itself and the database server instance, and then the socket will be used for further communication. So scan and database listener are only required for getting connected to an instance, getting that session started. Once that is done, scan listener and database listener is out of the picture. So DHCP works only when server is rebooted or scan VIP and server VIP initiates for IP renewals. If DHCP server is not available during reboot, clusterware might crash and will not start. This is the key point you need to understand, that if you are going with this complete DNS architecture. So your DNS and DHCP admins must give you properly configured, highly available information to be used by clusterware. So this concludes our basics. The takeout from this slide is the Oracle Home for ASM and clusterware in new installation is shared. ASM will be used for OCR and voting disk. Then you have to configure the whole clusterware using GNS or static scan IPs. There's a new architecture which is put in place for net services, that is connecting to single scan name and having 3 scan VIPs and 3 scan listeners. You will have only one GNS static VIP and GNS listener if you want to go with GNS route. And in GNS route, all the IPs for scan VIPs and listener and all the other application VIPs will be coming dynamically from DHCP. Other option is to use 3 static scan IPs and have all the IPs configured statically.
So don't use GNS. So scan will be used in either case. Scan cannot be skipped. Question you have to think about is, are you going to get static IPs or dynamic IPs? That is the one thing. And the decision that will be made towards any of these steps is based on how large your clusterware is, or how easy you want to maintain your clusterware. Thank you.